Hi, welcome to the class. Today we will discuss about uniform circular motion. So, uniform circular motion, as the name suggests, it is a circular motion, means the object is moving in a circular path. But what do you mean by this uniform? So, for that we need to understand this motion in detail. So, an object is there whose mass is m and this object is moving in a circular path. So, since the object is moving in a circular path, it is a circular motion. Now, we assume that the object is moving in the anti-clockwise direction like this. So, what will happen? Since the radius of this circular path is going to remain same, we are assuming that the radius of this circle in which the object is moving is not changing. So, in that case, the speed of the object will remain constant. The speed of the object will remain constant. Now, where will be the velocity of the particle will act? Now, you need to understand that speed is a scalar quantity and velocity is a vector quantity. So, scalars are those which do not have direction, they have just magnitude, whereas velocity is the one which have magnitude as well as direction. So, in this case, since the speed is constant, so the magnitude of the velocity will be constant. It means the velocity will not increase or decrease. The magnitude of the velocity will not increase or decrease. But as you can see, as I told you, the velocity will not be increasing in magnitude, but the particle is changing its direction at each and every point. So, suppose we imagine this to be a thread at which a mass of object, a mass m is being hanged and it is being rotated like this in this circular path. So, the speed will remain constant, which is a scalar quantity, and velocity, which is a vector quantity, will change. How it will change? If you cut the thread at any instant of time, suppose the thread is being cut at this point here. So, where will be the object moving? So, object will fly like this. If the thread is being cut at this point, where the object will move? The object will fly like this. If the object is being cut, if the thread is being cut at this point, where the object will fly, it will fly like this. So, what these things are giving us? These things are giving us, these tangents are giving us the direction of the velocity. So, the velocity is being acted, or the direction of the velocity is along the tangent at that particular point. So, if a tangent is being drawn at this point, the velocity will be acting in this direction, which is the tangential direction at this point, and at this point the direction of the velocity will be along this tangent. So, this is the direction of the velocity. At this point, direction is changed. At this point, direction is changed. The magnitude of the velocity remains constant, but the direction of the velocity is changing. Now, since velocity is a vector quantity, so it depends on two factors. It depends on the magnitude and it depends on the direction. Now, the magnitude is not changing. At each and every point, the magnitude is same, because whatever force is being applied on the object is not changing. So, velocity will change as the direction of the velocity is changing. How the direction of the velocity is changing? The direction of the velocity is changing because at each and every point the velocity is acting along the tangential direction. Now, the velocity changes because the direction of the velocity will change, and hence, since the velocity is changing, this will be an accelerated motion. As we all know that rate of change of velocity is acceleration. So, uniform circular motion is an accelerated motion. Speed will remain constant, velocity will change, and then this motion will be an accelerated motion. Where will be the direction of this velocity? Direction of velocity will be along the tangent at any point. So, now I will come to something important which is known as centripetal force. Now what is the centripetal force? It is a force which is required to do the circular motion. So when you want to do the circular motion, we need, what do we need? We need this centripetal force. So centripetal force is a force which is required to move the object in the circular path. So, but this force doesn't come on its own. It requires something else to generate the centripetal force. So suppose this is a thread, this is an object, and the object is being tied with a thread. Now if you hold the thread here and you start rotating this object in a circular path, the weight of the object is downwards, acting downwards. There will be a tension in the string. A tension in the string, and this tension, because of this tension, a centripetal force will be provided. So in this case, this tension is providing the centripetal force. Now if you take Earth and we take Moon to be here. Now Moon is revolving around the Earth in the circular orbit. So what will happen? There is a force of gravitation which is acting between these two, and this force of gravitation is providing the necessary centripetal force for the rotation of the Moon or the revolution of the Moon around the Earth. In a similar way, we have nucleus which is positively charged, and around the nucleus we have electron revolving. Now there is an electrostatic force which is acting between this negatively charged electron and positively charged nucleus. So because of this electrostatic force, there is a centripetal force which is being provided, or which is being there because of this centripetal force. So centripetal force doesn't come on its own. It is always generated by some other force. In this case, string and mass system, it is being generated by the tension in the string. In case of Earth and Moon or Sun and any other planet, it is being generated by the gravitational force. So this centripetal force is being generated by this gravitational force, and here the force is being generated by the electrostatic force which is acting between the negatively charged electrons and the positively charged nucleus. So this is all about uniform circular motion and centripetal force. Thank you.